Okay, so we are going to identify the anode from the following reaction. Now this is the same as the reaction given in the previous problem to determine the reducing agent. So it's actually going to be really easy. So the reducing agent we determined in the last problem was just plain old aluminum, not aluminum 3+. And an important little saying to remember when you're trying to determine whether something's anode or cathode is cat, red, and anox. Or this might be red cat or something like that. But anyway, cat is cathode, is reduction. And anox is anode equals oxidation. I personally think anox is easier to remember than cat red or red cat. So you can just remember anox because it goes really well together, and then the other one is reduction. So basically, we need to find the anode. This is asking for the anode, so we need to find the oxidation. So if we determined in the previous problem that the Al is getting oxidized, we also know that it is it's the reducing agent. So the oxidation is happening here, but the thing that's causing the reduction in the copper is the plain old Al. So the anode would be the same in this case. The anode is always the same as the reducing agent, but it's important to know if you're asked, the same question with a different reaction. If you didn't know how to find the anode, you could just solve for the reducing agent, but something that's also helpful is if you draw the galvanic cell. So these are the two separate containers. This is the salt bridge, and then this is where the electrons are flowing. So if you have Cu2+ on this side, and then you have Al on this side, your electrons are going to flow from Cu2+ to Al in order to oxidize it. And so that is also another helpful way if you can remember the drawing and just point the arrows, right? So aluminum, just plain old aluminum, would be the anode for this reaction.